Greetings and welcome, friends. We're taking a look at last night's quest on page 71. What's that? Setenta y uno? No? Maybe? Actually, no. I just realized it starts on page 70. How embarrassing. We were talking specifically last night about solving systems using substitution. All right, and we're going to start with 21, but I'll jump around a little bit based on difficulty of the problem. So problem 21, it's step 1 of substitution says to solve one of the equations for one of its variables, whichever might preferably have a plus or minus 1 leading coefficient, right? And so notice the y in the first equation has a negative 1 leading coefficient. That would be the preferable choice right there. So that's the one I'm going to aim for in order to do this. So 5x minus y equals 16. We'd subtract the old 5x from both sides because I'm trying to isolate the y. So the opposite of y is equal to negative 5x plus 16, which, by the way, you might hear me call that negative y sometimes, but technically it's the opposite of y. And then I could just multiply both sides by negative 1 in order to make it positive, or divide both sides by negative 1, something like that. All good. Or you just opposite both sides. But yeah, the reason we have to call that opposite of y is just because we technically don't know if y is a positive number or not. So, right, opposite of a negative might not be negative y, right? It might be positive. So anyways, nonetheless, here is what's called our revised equation. And I'm going to say if this is truly equal to y, then I can switcheroo it with any old y, any old time. And specifically, the y I'm going to plug it in for is the other equation's y. Otherwise, we'll get a false positive for an infinitely many solutions situation, which is not what I'd want. So instead of y, I'm writing 5x minus 16 is equal to 3. And now I can kind of do some distributing here. 2x plus 15x minus 30 plus 18, 48, I think, is equal to 3. Combine some like terms, 2x and 15x is 17x minus 48 equals 3. Add 48 to both sides. Let's see, divide both sides by 17. And is x equal to 3 there? I think it is, yeah. And now in order to find its buddy, the old y that goes with it, best place to plug that is in the revised equation. So y is equal to 5 times 3 minus 16. Y equals 15 minus 16, or y equals negative 1. Not bad.
The book said 321.
Yeah.
Aha! Book has been wrong in multiple occasions. So
okay, for so long I was just like, how did they get 21? Because we did all our work right. And
good job, friends. Good job. We found an error in the libro. So yeah, and that, by the way, represents an ordered pair, which would be the intersection of both of those equations being lines. Not bad at all. Here's problem 25. And what's the challenge with 25 when we look at this? If I'm solving by subs, there's no like weak spot that I can target. All of them have coefficients, like they're wearing extra like body armor, and I can't solve for one of those conveniently. And the thing that this is going to end up doing is create fractions when I try to solve it. So I don't know. Let's say let's just solve for the second equation's x. I'm just picking one that seems to be kind of nice-ish. So 2x plus 7y equals 24. To solve for that x, I would just move the 7y away. Move it away. So 2x is equal to negative 7y plus 24. And then divide both sides by 2, right? And this notice the fact that the coefficient existed forces me to have a divide step, and what does division do? It potentially creates fractions out of things. So that's why we avoid the variables that have coefficients other than 1 or negative 1 as much as possible. I got you there. That's why. Negative 7 halves, y plus 12, right? 24 divided by 2 is 12. 7 halves is a no-go. I can't simplify that. 7 halves. So this is the revised equation. So let's take this, and if it's truly equal to x, that means it's equal to x all the time. So I'm going to plug this into the other equations. X. So I'm going to have negative 3, and instead of x, I'm replacing it with negative 7 halves y plus 12, plus 10y is equal to 5. This one's going to be quite the doozy. So let's distribute and see if we can solve this. Notice, even though this equation looks way more complicated than the ones that we started with, the benefit is that they only have a single variable represented, even though it's represented multiple times. Negative times negative is positive. 3 times 7 is 21. Halves, that still doesn't reduce. That's a shame. Minus 36 plus 10y equals 5. Fractions. So I'm going to have to combine these. In order to combine those, they're going to have a common denominator. Right, so in order to do that, this is currently over 1, so I'll multiply this by like what, 2 over 2. Right, you guys are all masters of the fractions, right? So I'll have, I guess I'll rewrite this out. 21 halves y plus 20 halves y minus 36 equals 5. I just kind of switched these a little bit there. So how many halves y's do we have? 41 halves y's. Minus 36 equals 5. Oh, ooh, I think I'm liking where this is going. Add 36 to both sides. 36. And I'll have 41 halves y is equal to, conveniently, 41. How do you guys like to get rid of this one here? It's currently being... Forget about it. We could divide both sides by a fraction, but that's like, ew, that's gross. Instead, we can flip and multiply. Multiply by the reciprocal, am I right? 2 41sts. Multiply by 2 41sts. And on the left, we get y by itself, which was our goal. And the 41s cancel out over here. I get y equals 2. Wow, all of that fraction work. But fortunately, it still came out to be an integer answer. So that's not too shabby. And where should I plug this? In the revised equation. Yeah, muchos trabajamos. So I'm going to get, let's see, do I have room over here? Yeah, sure. So I have x equals negative 7 halves times 2 instead of y plus 12. X equals, the 2's cancel out, negative 7 plus 12. So x is equal to, what's that, 5. So our solution would be the ordered pair 5, 2. Voila, right there. So yeah, that one was trickier because of the fact that none of those had a positive or negative 1 coefficient. It doesn't necessarily guarantee fractions, so for instance, if this 7 was an even number, it would have divided out nicely and that would have been great. Today we're going to learn a technique to deal with these situations to hopefully avoid that sort of problem. Let's see, last thing I want to look at is number 9. I know it's numerically out of sequence, but this one does happen to be a more difficult problem than the others in some ways. Well, as you can see, I've got some fractions already built into this one. I want to solve one of the equations for one of its variables. None of them have a positive or negative 1 leading coefficient, or regular coefficient, sorry. So which one should I solve for? I don't know, I could solve for that x, that y. Maybe I'll solve for this x? I'm not sure. Maybe. That sounds good to me. So 5x minus 4y equals 14. To solve for that x, I'll add 4y to both sides. And I'll get 5x equals 4y plus 14. And divide everybody by 5. Oh, and that's creating lots of fractions. Why? Why? 4/5 y plus 14/5. My goodness. So here's the old revised equation. I'm saying this is equal to x all the time. Todo de los tiempos. So where do I plug this? In the other equation for x, right? So not in the equation I just solved. Never can do that. No can do that. So I've got 1/3, and instead of x, I'll have 4/5 y plus 14/5 minus 3/2 y equals -4. So let's distribute this perhaps. This 1/3, let's see, here I am. So 1/3, I'm just going to multiply the numerators by 1, the denominators by 3. So this will be 4/15 y plus 14/15 minus 3/2 y equals -4. Wow, this is supposedly going to come out to some integer answers based off of the answers that they had provided. Let's see if that happens. So I'm going to have to combine some like terms, guys. Now, we actually have a couple choices. I could multiply each fraction by the part of the LCD that it's missing, or if you recall your skills from the previous course, you could kill all the fractions by fraction aside, multiplying both sides by the LCD. My little 4 just disappeared partially. So I don't know. Let's. You guys want to try some fraction aside? Let's. Between 2 and 15 and 1, what is the LCD? 30. All right. Multiply both sides by 30. What that's going to do is actually kill all of our fractions, which you don't have to. You can work with the fractions instead of eliminating them from the planet, if you're a kinder person, perhaps, but we don't have to do that. So let's see, 30 divided by 15 is 2. 2 times 4 is 8. Y. 30 divided by 15 is 2. 2 times 14 is 28. 30 divided by 2 is 15. Multiplied by -3, it's -45. Y equals, and 30 times 4 is -120. So notice it's just killed all the fractions. That's a possible technique. You don't have to use that technique. And now I can go through and combine these, and everyone loves integers. Yay, integers. So what's that going to be? -45 and 8 is going to be what? -37 y's plus 28 equals -120. Thoughts? What do I do now? Subtract 28. I like it. And if the book's answers are correct, hopefully, whatever number this is going to be divisible by 37. So that's -148. So I divide both sides by -37. So y equals, the negatives cancel out. Guys, what do you think? 4? Is that 4? That looks like 4. I believe it is. Sounds good to me. The negatives cancel, right? And yeah, 30 times 4 is 120. 7 times 4 is 28. 120 plus 28. Yeah, that's 4. Okay. Whew. Man, that problem is beast. But that's only half the answer. But we're more than halfway done the problem. So let's see. Plug it in the revised. X is equal to 4/5 times 4 plus 14/5. So x is equal to 16/5 plus 14/5. Hey, those already have a common denominator. So that's just 30/5, which is plain old 6. Isn't that nice? Isn't that special? So 6, 4 is our answer, written as an ordered pair. No es más mal. Good job, friends. Tienen un día el más bien del mundo.